Hi everyone. In the given problem statement, we are going to solve binary tree maximum path sum. A path in a binary tree is a sequence of node where each pair of adjacent node is the sequence has an edge connecting them. A node can appear in a sequence at most once. Note that the path does not need to pass through the root. So let us take the example. Let us take the root node of -10, 9, right child 20, and it has two subsequent node of 15 and 7. So a question might arise, how do you define a path sum? So a path sum, let's say, can 9, 10, 20, 15, 17, all of them can be a path sum? Answer is no. So a path sum could be a sequence, right? So it could be 9, -10, 20, 15, or 7. So the change, right, can happen at one place. So right here, right, it is like -10, 9 and 20, right? So only at one place it can happen. So let's say 15, 20 and 7 can be a path sum. 9, -10, 20, 15 can be a path sum. 9, -10, 20, 7 can be a path sum. But all of them cannot be a path sum. So here, right, this root node, it can be traversed to both left and right. But so this functionality, right, let's say A, B, and C. So this, like, dividing into both left and right child, right, it can happen once. But let's say if C again has D and E, right, it cannot happen there. So either it can be happening like this, D, C, E, or A, B, A, C, D in this fashion. Now let's say if I have to define my function, or if I have to write the pseudocode for solving it up, right? So let me type in def dfs of root in case not root, then we are just going to return 0. Now we can take in the left max, which is nothing but a traversal. So root dot left and right max, which is again dfs root dot right. Now a question might arise, right? Let's say we have a value -10. Okay. So if I include -10 in our total path sum, right, our path sum is going to get reduced. So it is essential for us not to include this path sum. So we're not going to include that. So for that, we can do, just to remove the negative number, we can take the maximum of left sum or 0, whichever is the higher. So in case if you're getting a -10 value, right, we are not going to include it. Similarly, we can also take the right sum, and it would be max of right sum and 0. Then we can take one more thing. So let us take this example, right? We are forming our root, or basically a path where we are including both left child and right child. So in that case, right, it can happen only once in our total path sum, right? So let me create another variable which is called result, and it can be root dot val initially. Now I can check res of 0. It can be maximum of the current res 0 or root dot val plus left max plus right max. Straightforward. And at last we're going to return our root val for all the other cases. Only one thing can go, whichever is maximum, whether left child or right child. So it will be root val plus maximum of left max or right max. And at last we can just say, we can call this function dfs root, and at last we can say return result of 0. Now let us traverse it up, right? So we are at the root node, which is -10, which is fine for now. Or let us take this example. 1, 2, and 3. Initial result value is 1 because we are at the root node. Now it is going to the left child. So once it gone to left child, it is going to return. So here, right, it is going to form all these values, and right max is root dot right. So out here, right, if I calculate it up, so res 0, right, max of current res 0 plus root val. So root val is 2, and currently left max, because it does not have any left max or right max, so it would be 2. So it is going to get updated to 2, and the current value, it is going to get returned, right, it would be just 2. Similarly, we are also going to do the right max of from 1, so it is going to also return 3. Once it has returned 3, right, now here left max and right max are 3. So I'm going to write the formula, which is result of 0, max of result 0, left max plus right max plus root dot val. So here, right, it would be 3 or 2, 3 and 1, 5. So our result, right, is going to be 5. Similarly, right, if I do it up, so it is going to get returned 9. Here I'm going to come. So if it's -10 out here, right, it is going to return 0 because of the logic that we have written out here. We are going to return 0 out here. Similarly for 15, right, so both of them will get added. So 15 is getting returned and 7 out here. Then 20. So again, we are going to call this formula out here. So it would be 15 plus 7, 22. 22 plus 20, it would be 42. So as of now, right, the result value is going to get updated to 42 because it is the maximum value that I have got. Now we are going to again call this function res0 or max of left max plus right plus root val. So it would be 9 plus 42 minus 10. So it would be, I think, 41. So 41 is not greater than 42. So maximum path sum, right, is going to be only these 3 characters or these 3 nodes. So it is going to form the maximum. Although this is simple to understand, but I would ask you to try to understand using diagrammatically how we are traversing all the nodes and how we are calculating the sum. It is a recursive solution, so it might be a little bit complicated for anyone to understand, but I'm hoping that once you see the Python solution, which would be a few lines of code, so it would be very straightforward for you to solve it up. So now let us jump to the Python solution. The first thing that we're going to do, right, we are going to calculate our global value of res0, or let me type in res for now, which is going to be root.val, initializing it up. Then our calling the function dfs, where we are passing the root. As all of our dfs function, you have to check if root is not present. If not root, then we are going to return 0. In other cases, we can have the left max variable, which is going to contain the recursive call. So it would be root.left child and then right max dfs root.right. Then one more thing to calculate it up. So I do not want the left max or right max to have negative values. So what we are going to do, left max equal to max of left max odd 0. So in case it's a negative value, right, the left max would be assigned to 0. Then right max equal to max of left of right max odd 0. Now we are going to check for the result 0, the global, which is going to be maximum of res 0 or the current root.val plus left max plus right max. Or we can return our root.val plus maximum of only one, left max or right max. Now we are going to call this function, so dfs root, and at last we are going to return our result, which is stored at index 0. Let me run the code. As you could see, the public test case is passed. Let me submit it up. As you could see, it's getting 92.32% of the submission, and it's a linear time, so we are traversing all the nodes once, so our time complexity would be big O of n. So that's all for this video. See you in the next one.